This is the Promoting Higher Order Thinking Skills Through Explanations lesson of the module. And the question we want to ask in this lesson is, do students really know what they're doing? Too often students learn a list of steps, or they write down numbers, and they really don't have good reasons for doing what they're doing. They really don't understand what they're doing. So I would pose, first of all, that there is a necessity of asking why. We ought to be asking why in our classrooms constantly, throughout lessons, when students are doing examples, when we do examples. We ought to be asking why. And there are a number of reasons for this. One is simply so that because many students simply memorize steps to take. We want to avoid that, because the reason is, when students simply memorize a list of steps, if they don't have an example, or if they don't have a list of steps for a different problem or a slightly different application, they really don't know what to do. When we ask why and we force them to answer that question and understand what they're doing on one problem, then that allows them to develop the ability to apply those same strategies to other situations. Another reason is that why we don't want them to memorize is because anytime we're memorizing, we are also running the risk of forgetting those steps. And a lot of times students forget the steps that they had learned to do a particular problem, and because of that, they're completely lost. Another reason we want to ask why is because this forces thought. Asking why forces them to think about the math behind every step. It also forces them to think about what they're writing down. Why did you just do that? We ought to be asking them that as they work on problems and as we do problems in our classroom. Why did I just do this? Why did I write down this number? And by doing that, we force our students to think about what is going on and what they're actually doing. I think one thing kind of sums all this up, and that is, knowing why on this problem helps determine what on the next. In other words, when we get our students to answer the why question on the problems that we're doing, all of those reasons will develop in them thought processes and strategies that will help them determine what to do on the next problem. Just like we mentioned before, and applying them to different situations. They can take the knowledge that they have and extend that to other applications. And that's a critical skill that students need to develop. Right, next I want to think about the fact that explanation equals understanding. And this is something I think we overlook sometimes. The ability of a student to actually explain what they're doing as a sign of the fact that they understand it. Not giving cookie cutter responses, not just saying what they think we want them to hear, but really putting things in their own words, explaining what's going on from step to step, and not necessarily even using 100% mathematical terminology, but what are you doing, and explain to me how you got to that answer. What was your thought process? The idea here is a step-by-step breakdown with reasoning behind the steps. And that, I think, is really important. It develops their analytical thinking skills, and also just doing things with a purpose, having a reason for each step. Some ideas we can try. Some of these I have done, and some I haven't. But one I do with my 7th graders, particularly when we're learning to solve equations in pre-algebra, is 2-column solutions. When we're solving an equation and they add 5 to both sides of an equation, they have to write next to it in the second column, why did you ask 5 or add 5? And they would put, because I'm undoing a minus 5. And obviously that has other ramifications too as we move forward to geometry proofs. It gets them used to that 2-column structure, but it's a good way to get them to think through the step-by-step breakdown of the problem and give a good reason of why they're doing what they're doing. They're not just adding 5 because it seems like the right thing to do. They're actually doing it with a purpose. And that seems to be helpful. You could do this with a number of different things, even on elementary level. Another strategy, and this is the one that I haven't used yet, but using Audacity to record an explanation of how to solve a problem. This would be useful, particularly in combining it with the next of the ideas. But even just getting students to visualize a problem in their head as they listen to an explanation that one of their classmates made can be helpful in building abstract thinking and visualizing things. But as the students record their explanation, obviously in a recording they're going to want to do it well, and they may have to do it multiple times to get it right. And again, all that repetition and having to express themselves verbally, really tests whether they understand the problem. And the repetition really drives home that understanding. And the last of these, and this is what Audacity, that sound recording could be combined with, is a PowerPoint presentation. Now this is something I have used. I actually have an example from last year. In my geometry class, we obviously discussed the Pythagorean theorem, and I make a point of going over a number of different proofs for the Pythagorean theorem. And seeing those proofs is helpful for my geometry students because then they see how a proof can be constructed. They see that something can be proven different ways, and that can also help them then develop their own proof skills, proof writing skills. So I give you an example here of one of my students, and this is a presentation that they had to make in PowerPoint, and it was a presentation they made of somebody else's proof. But they had to read it, and given as it was written for math people, the explanations weren't always that clear to a high school geometry student, so they had to discern what was actually going on, and then they actually had to give this in class. And this student, Eden, did a particularly good job, and you can even see how this develops their creativity and things as they move forward. So here you have, she made a title slide, some nice design. They start with their givens and setting up the situation, and all this she's explaining to the class. And I'm not going to go through the whole proof, but you can see the different steps and some different strategies. Here she used color coding to show what segments came from which triangle, and that was really helpful for her and her classmates to understand this proof better. Showing a previous step and then showing the next step. And again, notice she's giving reasons for every step. She accompanied this with more explanation in class. And finally ended up with the Pythagorean theorem, a squared plus b squared equals c squared. So this is just one example, and these 3 ideas, 2-column solutions, using Audacity, and PowerPoint presentations, are really just the tip of the iceberg as to how we can challenge our students to answer the question why, and in doing so, promote those higher order thinking skills. Okay? And this also goes along with everything that we've been doing in this module about understanding the basics of computation, because if they don't understand that really, then they're never going to be able to explain this. Alright, so If you were to try this in your classroom, obviously you wouldn't necessarily start with the Pythagorean theorem. You might start with a basic multiplication problem. But you could move from that and then go forward into more complex problems and having your students trying to explain more involved solutions to those problems. So this is how we can promote higher order thinking skills through explanations and determine whether our students really do know what they're doing.